Alright guys, so yesterday we learned how to go from a z-score to a percentile, and we did that by using our second distribution and using our normal CDF, and then we typed in a low bound. So let's say I wanted to find the middle 10% or something like that. Type in our low bound and our high bound, and then we always made our mean 0 and our standard deviation 1. So for example, if I'm trying to find the area or the percentage under z-score of like negative 2.1 or something like that, I would type in something negative and something big, so negative 1,000, and then negative 2.1, 0, standard deviation, enter. This will be the percentage, so 17.86% of the curve will be underneath negative 2.1 standard deviations. So today what we're going to do is we're going to figure out how to go from a percent back to a z-score. So I'm going to give you a percentage and we're going to go back to a z-score. And the way we're going to do that is we're going to use something called the invert norm. Invert normal. So that's found by going second distribution, invert norm, and then it's going to ask you a couple different things. It's going to say, what do you want the area to be? So let's say, we'll just do a quick example right here. Let's say I want to find, I don't know, the 75th percentile, so it'd be P75. So if I were to look at my graph, the 75th percentile means 75% of the area is underneath the curve. So this is going to be 50 right here, so 75 would be right about here. Let's say I want to find the z-score of this number right there. So we type in the area, which is 0.75, and we want the area because the percentile, it's always left bound. We want the tail to be in the left. The tail can be in the left, it can be in the center, which will look like this. If I want to find the tail in the center, it'll look like that, and if I want to find the tail to the right, it'll look like this. So this is actually really nice. I haven't seen it before, they must have just added it. Takes a lot of the thinking and some of the difficulty out of it. So if we want a percentile to the left, we're going to go to the left, paste, it'll paste it in for us, and it'll give us that right there. So my z-score here, z, is going to equal 0.6745. So 0.6745 to the right, 0.6745 standard deviation, excuse me, to the right, will give me my 75th percentile. Okay, so let's just work through these here, and then I have kind of a real life example on the back. So this is actually wrong notation. It should be P85, and that's going to be the 85th percentile. So again, we're talking percentiles. So I draw my little normal curve here. I want 85%, so again 50 is here, so 85 is going to be right here. And I want to figure out what this z is going to be. So I go second distribution, invert norm, type in 0.85, 0. We want the tail to be in the left, because I want everything from the left down. That's good. So the shaded region's to the left. So that's going to be z of 1.0364. Okay. P of 12. So again, that's wrong notation. It should be P12, and that's going to be the 12th percentile. So now the 12th percentile is going to be on the other side. It's going to be right here. This is going to be 12% of the curve in this little area, and I want to find what the z-score is going to be. So I can already tell that because 12 is less than 50, I know that this is going to be a negative z-score. So I go second distribution, invert norm, 0.12 this time, mean 0, standard deviation of 1, and we want to find the left again. Tails in the left, meaning the shaded areas in the left. Paste. I get a z of negative 1.175. So that means 1.175 standard deviations to the left. If I go under that, that will be 12% of the curve. Let's do this one next. Find a z-score for the middle 99%. So that's going to look like this, a little bit different. I'm going to get 2 z-scores. I wonder how it's going to do this. We'll figure it out. Oh, I think I know why. Middle 99% is going to look like this. So it's actually going to give us a positive and a negative z-score around 0, because remember 0, a z-score of 0 is going to be the mean. So I want to find the middle 99%. So I go second distribution, invert norm. I want 99%, mean still 0, standard deviation still 1, that'll never change. And I want to find the center instead of the left or the right, because the shaded area is in the center here. Hit enter. So now it's going to give me two standard deviations, negative 2.57 and positive 2.57. So 2.5 standard deviations to the left, 2.5 standard deviations to the right. That should be about 99% of the data. Find a z-score for the top 40%. So the top 40%, I always like to draw the picture. Makes it a little bit easier. So remember, 0's in the middle, standard deviation of 1. Top 40% is going to, well, if I drew a line down here, this would be the top 50%. So I want it to be a little bit less than that. So if you'll notice, the tail now is to the right side. So I go second distribution, invert norm. I want the 40th percentile, but I want it to be the top 40th instead of the bottom 40th. So I make my tail to the right. It should give me a z-score of something between 0 and 1. So it's going to be 0.2533. Cool. Find the z-score for the IQR. So eventually we're going to do something called a confidence interval. And that's why we're learning this stuff in the first place. So this is like a 50% confidence interval. Doesn't really make sense to you right now, but it will hopefully one day. So the IQR is going to be from the 25th percent to the 75th percent. So that's going to be the middle 50%, what I'm looking for here, the area of the box. So this is going to be the middle 50%. Okay. So I can do this a couple different ways. I could do invert norm, and I could just, here we go, invert norm. And I could do the 25th percent and know that the 75th percent is going to be the same thing, but it's going to be the positive version. So if I watch this, if I go to 0.25, I make my tail to the left, enter. So I know this needs to be negative 0.67, which means this is positive 0.67 because it's going to be symmetric around 0. Another way to do it, and the way that we would probably do it now with our new tool, invert norm, we want the middle 50%. So we want the area to be 50%, and we want it to be found in the center. Enter, and that'll give me the same z-scores. Okay. Find the z-score for the top 15%, also known as the 85th percentile. So top 15% is going to be right here. So if I go second distribution, invert norm, 15, 0 and 1, I'm looking for a z-score, so I know the 0 and 1 need to be my mean and standard deviation. I'm going to the right. Boom. 1.0364. So I know that's going to be my z-score. Cool, so that's kind of the nuts and bolts, how that works. And then I have a little real-life example here for you. Make sure you can see that. Good. The time spent waiting for a heart transplant is normally distributed with a mean of 127 and a standard deviation of 23. So if I draw my normal distribution, I know the mean here is going to be 127 days, and the standard deviation is going to be 23.5. What is the shortest amount of time spent for a patient in the top 30th percent of waiting time? So the top 30% is going to look like this. So there's probably a couple different ways to do it. If you're clever, you can do this all in one button on the calculator. I don't know if I'm going to teach that to you though. Maybe I will. 23.5. And we want to find out what number goes here so that 30% is in the top. So what we need to do, in order to find the number, first we have to find our z-score. So again, I'm going to draw another, this is going to be the exact same curve, but instead of having 127 in the middle, we're going to have 0 in the middle, and we're going to use 1 as my standard deviation, and we're going to find the top 30%. Okay, so we get the calculator out. go second distribution, invert norm, because we want to find, we're going from area back to z-score. We want to find the top 30%. Paste, enter, so we get z to be equal to 0.5244. So we have a z-score now, we have a mean, and we have a standard deviation. We can work backwards to find out what goes here. So the way we do that is we use our z-score formula, z equals x minus x bar over standard deviation. So z is going to be 0.5244 equals x minus x bar, 23.5, divided by a standard deviation. Oh, wait, it should be 127 divided by a standard deviation of 23.5. And then you just solve for x, so multiply by 23.5, enter, and then go ahead and add 127 to it, 139. And that's going to be days. So someone that waits 139.3 days is going to be in the top 30%. Okay. Find the longest time spent for a patient waiting in the bottom 10%. So I'll do this one without the algebra. You'll probably enjoy it more. So again, this is going to be my mean, which is 127. This is going to be my standard deviation, which is 23.5. We want the bottom 10% now, so the bottom 10%, the tail is going to go to the left. And we got to find out what number goes here. So notice this number is not 0, so I can't use my z-score formula. I have to kind of find my z-score first, and then work backwards like I did up here. This is the exact same problem, but with a different area under the curve. So I'll show you how to do it with the calculator. Go second distribution. If you want to, you can set up exactly how we did here, where you go invert norm. We want the bottom 10%. Make sure you enter that in as a decimal. We want it to be left, right? I'll find my z is going to be negative 1.2815. And then I'll use that and I'll set it equal to my formula, x minus x bar over standard deviation. So I got to take that, multiply by 23.5, and then go ahead and add 127 to it, and I get 96.88 days. So somebody that waits about 96.88 days or 97 days is going to be in the bottom 10% of wait times. The easy way to do that one, and I'm sure some of you have figured it out already, go second distribution. You can change these parameters here. So we want the bottom 10%. We want our mean, don't make it 0, make it 127. Make our standard deviation 23.5. And we want that to be left, right? So normally, I would always recommend defaulting to 0 and 1 because we always want z-scores, just makes everything easier. But if you don't like the algebra, you can obviously do it this way. You should get the exact same thing that we got over here. All right, good stuff. Peace.